Let's solve this question using our guru. Is a student's preference of type of learning environment independent of their level in school? A book publishing company was interested in knowing this. They randomly selected 200 students in higher education and surveyed them. Use the data below and a zero point zero 0.05 significance level to test this interest. All right, great. I see that we're going to be doing a hypothesis test here. And just want to see if the two are independent. I'll look at the data below, and I have two qualitative variables: type of student, type of class. So this is a perfect situation for a chi-square test of independence. So our hypothesis statement here would look like, oops, preference of learning environment and school level are independent. And then our alternative would be preference of learning environment and school type are dependent. So these hypothesis statements are just a little bit different than what we've done before in that they are complete sentences pretty much stating the two variables are independent in the null and the two variables are dependent in the alternative hypothesis. Let's go back to that table. We're going to need to get this information into our guru so it can help us out. So I will click into our guru. So we're going to want to go to open up data. And this is important here. We're going to click on data import, but we're going to create a table. This is not raw data. This is summarized data that's been given to us and shared with us as a contingency table or a two-way table. So our table had two types of students. So I'm going to need to add another row. You can see here when you hover over this icon, you can add another row. And we had two different types of classes. We have one here. So if I hover over this one, it's going to allow me to add another column. If I double click in here, I can start to name everything. Graduate student, undergrad, so those you click directly in the boxes and you can title them. To get this here, these column headers, we're going to click on there and then we're going to be able to change what it is up here in this box. So this will be a face-to-face class, and this one here, click on there, and now you can change this to online. So we have the framework here, and now we're going to put the numbers in. And so double click there and I can type 50, and then I'm just going to use the tab key here and it'll navigate me through the table. Oops, I'll have to retype that. Accidentally change this back to undergrad. Okay, so we have our table. This is wonderful. The next thing we're going to do is kind of put what's called a row label in. So this is the type of student. So our rows are representing the type of student, and our columns, we're going to give it a label. The columns represent the type of class. In the place of variable name, I'm just going to put the word number. And what that is reminding me of is that what each cell represents is the number of students who fall into each of these classifications. For instance, we have 65 undergraduates that, and as I trace up, I can see that prefer face-to-face classes. So this just gives us the pure number. And let's save the data set. Let's save it as book publisher survey. So book pub survey. You name it, anything you'd like. Excellent. So we have that data saved. Now that we have that table saved that contains our summarized data, we're going to close up the data panel. I'm going to go to analytics, click on analysis, and contingency table is right about halfway down. So it wants us to select a data set. So we're going to select, I have quite a few here, our book publisher survey, book pub sub survey, as I've called it. It'll recognize my variables now, type of student and type of class. As long as these are different, it doesn't really matter which one's factor 1 or factor 2, but I'm choosing each. And then frequency is number. We're going to do a chi-squared test of independence, so I'll click on that. My significance level was 0.05, so that's the default here, so wonderful. And at this point, we'll just click the preview button and let's look at the output. Excellent. So it gives us the table back, so you can double check that you've got everything in order. Also, you can see it created those totals for us. There's a reason we did not enter them, because the totals can be created by software. Here's our chi-square test of independence. I see a 1.36 as the chi-square test statistic. And then I see my p-value, my probability value at 0.2428. So I'm going to take this information. Also, if we scroll down, we see a picture, graph of this. Also, we will see the expected counts. That's something, if you were doing this by hand, that could be interesting to see, or if you needed to find one of these expected counts for an assignment, they're down here. So let me glance at those numbers one more time, and we're going to go back. So my chi-square test of independence was equal to 1.36, and my probability value was equal to 0.2428. Now I'm going to just put that directly next to my significance level of 0.05. And I'm going to now assess which one of these quantities, because I'm going to do a comparison here of the probability value and the significance level in order to make a decision. And I see that my probability value is much larger than or greater than my significance level. So that means we're going to fail to reject our null hypothesis. Here is where the threshold of significance or unusual or strange or weird happens. And you can see that, in order to reject, we would need to have something that was less likely than that. Our probability value is more likely. So that tells us we're going to retain our null. I'm going to circle it here. And that our alternative hypothesis we're now going to ignore. So the nice thing about these kind of tests is that, your hypothesis itself is a sentence. So your summary statement is practically written. We're just going to layer in the idea that the sample evidence or the sample data suggest that learning preference and school level are independent. So this is our overall statement, just kind of repeating back what the null says and just adding in the extra bit that says that this was all decided using sample evidence. I hope this was helpful.